All right, so um, these are the first video notes that we're going to upload for you guys. We plan on doing this twice a week for you. This is all kind of uncharted territory for us as well as you guys, so we're just going to kind of see where this all plays out and how convenient this is for everybody. So we plan on doing one every Tuesday and Thursday for you, along with an assignment to go along with it. So yeah, so let's get started on this one. This is all just going to be review of what we did before spring break. So this first week's going to be a pretty simple one for us, just to kind of remind us of what we were getting into, which was rational functions. A lot of you probably started graphing it. This was probably the first thing you did was inverse variation, just to kind of introduce you. So we're just going to kind of hop back over to that. So let's get started on that. So direct variation is something that you guys should remember from, I don't know what I'm doing. Something you guys should remember from Algebra 1. This is the simple stuff. This is the stuff like y equals 2x. A lot of you probably called it proportional. That was when it's linear and it goes through the origin. It was a proportional function. It was a direct variation. While if it did not go through the origin, like if I were to add 1 to this, or add 10, or add 7, whatever you want to call it, it was not proportional anymore. It was non-proportional, and therefore it's not a direct variation. That stuff, like I said, is stuff that you learned in Algebra 1. Nothing new there. But the new part is this inverse variation, which instead of being a times x, now y is going to equal a times 1 over x. The reciprocal of x, or kind of, so to speak, the inverse of x. That's what we're going to kind of get into and get into graphing now and all that kind of stuff. Again, this is a special kind of rational function, though. It's an inverse variation, meaning if I were to take a over x and add anything to it, like 1 on the outside, it would not be an inverse variation anymore. It would just still be a rational function. So this is the simplest of the simple, and you're going to see kind of why that is here in a little bit. Yeah, so we're skipping kind of the classifying them from their equations. That was kind of easy and stuff like that. So we're just going to jump right into classifying the data that we're given, right? So if we're given data, if we're given 4 sets of pairs here, we want to know whether it's a direct variation, whether it's an inverse variation, or whether it is neither, which could be the case. It could be a polynomial. It could be an exponential function. It could be anything, right? So classifying data is always important. We always want to be able to make use out of data. Data is really useless unless we can make a pattern out of it, right? So we want to analyze that data, see which pattern it follows, whether it follows the pattern of a direct variation, whether it follows the pattern of an inverse variation, and then we can go from there. So what we're going to kind of do is look at what's always true about a direct variation and what's always true about an inverse variation, and then I'm going to kind of make it into simpler terms for you after that. So when we talk about a direct variation, right, we know y is always equal to a times x, right? That's always true. So I want to know what happens. So a is always the same, right? When y equals 2x, a is always 2. Right, so y is always 2 times greater than x. So if x is 4, then y is 8. If x is 10, y is 20, so on and so forth, right? But the 2 doesn't change, right? So what would a equal? What would that 2 equal in this case? So if I wanted to solve for a, that would be very easy. It'd be a one-step equation. I would just divide by x, both sides. X's would cancel, and I'd be left with a equals y over x. A equals y over x. So that always holds true. Just like, we can solve for anything. So a always equals y over x, while over here, if I wanted to solve for a, my inverse variation, right, I'd be able to do that just by multiplying by x. That's a horrible multiplication sign. Sorry, this is going to take some getting used to. So we would just multiply both sides by x. These x's would cancel, and x times y would stay the same. So this would actually simplify into a equals y times x, or x times y. Right? It doesn't really matter. So my a is always the same, and it's always going to equal kind of whatever the relationship between y and x is in that case. In the direct variation, a is always equal to y divided by x. In an inverse variation, here, I'll point to you. In a direct variation, a is always equal to y divided by x, while in an inverse variation, a is always equal to y times x. So that's really important in classifying data, and I'm going to kind of simplify that a little bit for you. If you're not really an algebraic person, all that kind of doesn't really resonate with you well, then let's make it kind of into a sentence form. So, direct variation. Basically, all I'm saying is, and this is really hard to write, guys, because my palm, I can't rest the palm of my hand on the screen, or else it will mess up. So bear with me here, but I'm gonna try my best. So a is always the same. A always equals y over x. So just in sentence form, that just means if if y divided by x. Okay, this is bad. I'm not gonna waste too much of your time, I promise. Okay, so if y divided by x is the same, for all pairs, they're all the same, they're all equal for all the pairs in your data list, then it is a direct variation. I'm just going to put DV for the sake of how bad that handwriting is, so hopefully you're listening. If y over x is the same for all pairs, right, if they're all equal, then it is a direct variation, right? Similarly, for an inverse variation, I'm going to try my best to write better. I promise it'll get better. I can write it all over here, and I can rest my hand. So, similarly, if y times x is the same for all pairs, right, then, see, that's what happens. Then it is an inverse variation, IV, not your typical IV, inverse variation, right? So that's basically the case here, right? And that we're going to just apply that to all these tables here that are given. It's going to be pretty repetitive, should get pretty simple by the end. But we're just going to say, okay, well, let's try y over x for all these values and see if they're the same. If they're not the same, I don't know what I just did. If they're not the same, then we just try the other one. If they're not all the same, then we'll try, well, what about y times x? And if they're not all the same either, then obviously it's going to be neither, right? Pretty simple. So let's get started on that. So let's see first if it's a direct variation. Y over x would be the same, right? So y over x. In this case, it would be negative 12 over 2, right? So let's try it. Let's try negative 12 over 2. That equals negative 6. Right, so if this were a direct variation, then all of these pairs would have to divide to be negative 6. All of them, right? So let's try the next one. Let's try negative 6 over 4. Negative 6 over 4. That's going to be negative 3 over 2, which is obviously not equal to negative 6. Those aren't equal. So I know that this is not a direct variation. Right, so all that is useless. Not a direct variation. So let's try inverse variation, meaning all of them would multiply to be the same exact number, right? So negative 12 times 2. Negative 12 times 2. That's going to give me negative 24. So if this is an inverse variation, sorry, I couldn't talk. If this is an inverse variation, then all of these should multiply to be that same exact number. So let's try the next one, negative 6 and 4. That also equals negative 24. So far, so good. You never want to stop with just 2 values. Never, right? At least go to 3, but obviously we're going to ask you to do them all, right? Always be sure about it. Always make sure. Always check your work. So let's multiply these. So negative 4 times 6 is negative 24. That also matches. And then finally the last one, negative 3 times 8 negative 24. So all of these match. Yay, all of these match. All these are the same. So this is an inverse variation. And that looks just terrible, but you should be listening to me and writing this down. An inverse variation is A, right? Because y times x always gave you the same number, right? And that's what we told ourselves. If y times x, let me get the little pointer guy out. If y times x is the same for all pairs, then it is an inverse variation. And that's exactly what happened here. Y times x was negative 24. Y times x, negative 24. Y times x, negative 24. They all equal the same thing. So yeah, hopefully this is starting to make a little bit of sense. Once it starts getting repetitive and tedious, that means that's a good thing. That means you get it. So let's try the next one. So first of all, we'll start with y over x, right, to see if it's a direct variation, y divided by x. So let's take this first pair, 2 over 1. That equals 2. Pretty simple, right? So basically we just want all of these divisions, all of these ratios to be 2, right? So then my next pair is 4 over 2, which, what do you know? That's 2. That's perfect, right? So far so good. Remember, do not just stop with 2 though. Always keep going, and you're going to see why here after we do this third term, 8 divided by 3, which is not 2. That's just 8 over 3, right? That's 2 and what, 2/3? That's 2 and 2/3. That's not the same thing. These are not equal. Not equal. Right, so then it's not a direct variation. Right, not a direct variation. Simple as that. So let's go to try an inverse variation again. Maybe it's the same one. So I'm going to multiply y times x, 2 times 1. And this is a different problem. 2 times 1 is 2. So again, we want everything to be 2. And from what most of you may see already, 4 times 2 is not 2. That is 8. That means these are not equal. So this means it's neither a direct variation or an inverse variation. So it's just neither. It could be anything. Oh my goodness. I'm sorry. Neither. That's not bad. Okay, neither. So this is neither a direct variation or an inverse variation. So it just stays with neither. Right. Coming down to C, I'm writing very big. I realize this. I'm sorry. So coming down to C, we're going to try y divided by x again, right? Y divided by x. So this divided by this, right? So on and so forth. So we're going to do it. 20 over negative 4, right? That equals negative 5. So I want all of these ratios to be negative 5. If they are all negative 5, then this is a direct variation, right? If not, then we'll have to go to the inverse variation test. So let's try the next one. 15 over negative 3. That's also negative 5. Okay, we're getting somewhere, right? We're getting somewhere. So then we try the next one. 10 over negative 2. Negative 5. Looks good so far. Let's try the last one just to be sure. And again, it is negative 5. So this one, we tried the first test. It worked. So it's an easy one. So it's direct variation. Hey, I'm getting a little bit better at writing. This is terrible. I'm so sorry. Okay, so direct variation, right? Because, again, just to make sure we're all okay. Jeez, what's happening here? Oh, sorry. Just to make sure that we're all good. That's a direct variation. Sorry, my thing was messing up. I'm sorry for the long pause. Just to make sure we're all good, if y divided by x is the same for all pairs, then it is a direct variation. And what happened down here, all of the y over x for all pairs was the exact same, negative 5, right? So if you could just remember those two sentences, those are the really main things of classifying whether or not it's a direct variation or if it's an indirect variation. So let's try this last one. Again, start with direct variation test, y divided by x. So this is going to start with 60 over 1, which is 60. Right, so I want all of my ratios to be 60. Now if I try this next one, 30 divided by 2, that's obviously not 60. That's going to be 15. These are not equal. So it's not a direct variation. Simple as that. Right? come over here and try the indirect. I'm sorry, indirect is a mistake. A lot of people I make it too. A lot of my students are making it. It's not indirect. It kind of seems the most logical way, but it's not. It's inverse variation. So let's try the inverse variation test. Right, so y times x. So 60 times 1. Hopefully we all know that's 60. So then we go on, right? 30 times 2. That's also going to be 60. Okay, that's promising, right? 20 divided by, or times 3. Also going to be 60. 15 times 4 is also 60. All of these are the same. Therefore, this is an inverse variation. Right, inverse variation. So just to kind of recap. Again, I know I've said this a billion times, but it really just comes down to these two sentences. If y divided by x is the same for all the pairs, it's a direct variation, just like here. Oh, this is horrible. Okay, just like over here, right? Y divided by x, y divided by x, y divided by x. They were all the same, so it's a direct variation, right? Similarly, if y times x is the same for all the pairs, then it's an inverse variation, right? Just like this one here. Y times x was negative 24. Y times x, negative 24. It's all going down to an inverse variation. So yeah, not bad, not bad. Now, we got to be able to write an inverse equation based off of that data, right? Based off of that data. So, let's do that. What color? I'm going to use pink. Okay. So, this is basically just telling us that this varies inversely. The variables x and y vary inversely, right? And when y equals 4, x equals 3. I kind of said that backwards, but it really doesn't matter. And y equals 4 when x equals 3, right? So write an equation that relates x and y, then find when x equals negative 2, right? So the thing that I'm going to go back to here, all I have is one pair, right? When x is 3, y is 4. I just have one pair. That's all I need. So this is an inverse variation. We said we can find a by just taking y times x and finding that a value. It really is that simple, right? So we found that out earlier. A always equals y times x. So, and if you look here, let me erase this really quick. If you look here, all I need to make an equation, sorry, all I need to make an equation is that a value, because y and x are always the same. X is your independent, y is your dependent. All you need is that a value. So we can find that a value by multiplying y times x, right? So that's all I need to do. So I'm going to come back down here. What is y times, I'm sorry, geez, my voice is killing me. So what is y times x in this case? 4 times 3, right? So 4 times 3 is 12, right? So that's my a value. So a equals 12 equals, a equals 12. So I can write an equation now. Why y and x don't change. So y equals 12 over x. Y equals 12 over x. Right? That's my equation. That's my inverse equation. Now I can find y when x equals negative 2 because I have an equation to plug that into. Right? I have an equation to plug that into. So that's my next step. So y equals, and I will start doing different colors here in a second. So y equals 12 over negative 2. Those are parentheses. Sorry, they look so bad. So y equals 12 over negative 2. Right, 12 over negative 2 is just going to be y equals negative 6. Right, so there you go. Right, you just find the a value based off of the 2 that they gave you. You get an equation out of that, and then you plug in the one that they're trying to find. It's really that simple, right? So let's come down here and do this. So this is kind of the same question, except now we're always going to have the same x value we're trying to find, but different variations of an equation, right? So this equation is going to be different than this equation. It's going to be different than this equation, so on and so forth, right? But we're going to be looking for the same x value. So let's get started on that, right? So this first one over here. When x equals 4 and y equals 5, what would y be when x equals 5? Sorry, I got confused there. Okay, so again, for all of these, you want to find the a value by finding what y times x is. That's going to always give you your a value. Then you get an equation out of it. Then you plug in that 5 into that equation to see what it is. Right, so it's going to be three simple steps. So first, I multiply these two. Right, so again, I'll write it just for repetition. A equals x times y. Yes, I wrote that backwards. It does not matter. Right, 2 times 3 is the same thing as 3 times 2. So that's okay. All right, so a equals x times y. Just for the sake of consistency, I will change that just to make sure we're okay. Okay, so a equals y times x. Right, so a then equals 5 times 4. So a equals 20. Right, so I can get an equation out of that now. My equation is y equals 20 over x. Y equals 20 over x. Right, so that's my equation. Now I'm just going to plug in to that equation. Right, so y equals 20 over my x value, which is 5. Again, these are parentheses. Right, so 20 over 5, that's just going to equal 4. So there you go. There you go, right? So my inverse variation of those two, when x equals 5, y equals 4. Pretty simple, right? Pretty simple. Let's use some different colors here. So, again, same process. A equals y times x. So I'm going to find my a by multiplying. So a equals negative 1 times 6, which is just negative 6. So that's my a value. So y equals negative 6 over x. That's my equation. Right, so then to plug into that equation, I just plug in that 5. So y equals negative 6 over 5. And that actually doesn't simplify. So that's going to be my answer. Y equals negative 6 over 5. Right, and again, this last one, that's going to be a big number. Oh, geez. Okay, so let's do red this time. So again, a equals y times x. Right, so we just got to find that a value, make it an equation, and then plug in this 5 that we keep wanting to plug in to find. Right, so 16 times 8. I don't feel like doing that in my head, so let's do it the old-fashioned way. 16 times 8. Right, 8 times 6 is 48. 128 should be. I am going to get my calculator just to make sure, because I don't want to make a fool out of myself. 16 times 8 is 128, yes. So that's my a value, right? A value equals 128. So that's going to be part of my equation. That I just found my equation just by finding my a value. So y equals 128 over x. And again, I just plug in that 5 that we keep wanting to find. Oops. Jeez. I'm telling you, this thing is not ideal to write on. Oh, my goodness. Okay. Sorry. Y equals 128. And then the 5 down there. Right? Just like we plugged in here. We plugged in there. We plugged in there. Same thing. We just got to plug in that 5 to our equation. So y equals 128 over 5. That's actually not going to simplify. So I'm done. Right? My y equals 128 over 5. That's an 8. Oh, well, you can see that, right? So again, when they vary inversely, all you got to do is find the a value by multiplying y times x, get the equation out of that because of your a value, and then just plug in whatever you're looking for. In this case, it was always 5, right? Pretty simple. So let's come down here and do this word problem before we go, just to see kind of what kind of applications can come out of this stuff. Right, so Billy's dentist determined the number of cavities. I can point along with it. Billy's dentist determined the number of cavities developed in his patient's mouth each year is inversely proportional to the total number of minutes spent brushing their teeth each session. Right? If Billy developed 4 cavities during the year while only spending 30 seconds brushing his teeth each time, how many annual cavities will Billy develop if he increases his brushing time to 2 minutes per session? Right, so they're saying, well, there's an inverse relationship between the amount of time spent brushing your teeth and the amount of cavities you have. Right, so let's see. right? So he had, where is it? 4 cavities when brushing for 30 seconds. Right? So we can say he had 4 cavities when brushing, right? So we don't know an A value, 0.5. And you might be wondering why I'm putting 0.5, because we want our answer in terms of minutes. We want our answer in terms of minutes. So let me kind of just explain. I know I kind of jumped the gun here. So we're just making the inverse relationship that he already has. He already has data. He has a y and an x, right? So I can even come over here and make a table, right? I can say, well, we have an x and a y, and he has 4 cavities when brushing for 30 seconds. Now 30 seconds, again, we want it in terms of minutes because that's what our answer is going to be in. Develop if he increases his brushing time to 2 minutes per session. So 30 seconds in terms of minutes is half of a minute, which is 0.5. Right, so we have a table here. We have a y value, we have an x value. So really what we want to do, I didn't even have to do this step because we didn't even do this step earlier. All we have to do is multiply to get our a value. Right, so our a value equals y times x. Right, so our y times x here is 4 times 0.5. What is 4 times 0.5? That is 2. So that's our a value. So our equation here, and I'm even going to erase this. I really didn't even need to write that. So our equation here is y equals 2 over x. Right? Y equals 2 over x. So then I can plug in. Right now I can plug in. Now he's asking me how many annual cavities will Billy develop if he increases his brushing time to 2 minutes per session. 2 minutes per session is our x value. So I just come over here and I'm going to plug in y equals 2 over, and I'm going to say, what about if it's 2 minutes? And 2 over 2 is 1. So my answer is Billy will have, I'm just going to put ... because I don't feel like writing. Billy will have 1 cavity. Right, Billy will have 1 cavity. So again, just to recap really quick, this actually goes hand in hand with, sorry guys. This goes hand in hand with whatever was happening up here, right? We had to find our a by multiplying y times x, make it an equation, and then plug in our desired value, right? It's the same thing down here. Same thing down here. We have our table. We have our 2 terms, right? We got to find our a value by multiplying y times x. 4 times 0.5 is 2. We make that an equation. We plug in our desired outcome here within 2 minutes, and we find our y value. And then we just apply it this time, saying Billy would have 1 cavity if he were to brush for 2 minutes, right? So that's it for our first video. Again, guys, this is all kind of uncharted territory. We're kind of going with you guys. We're learning with you in this aspect. We've never had to do a distance learning quite like this. This was a tool that I personally use for like review, so I could go through it and know that I've taught my students all of the stuff that I was going over for this, so there was no need for questions coming in. There was no need for interaction of any sort because they can go back to their notes and look. In this case, guys, again, this is just review, so this isn't really too pressing. It's not going to be too challenging for a lot of you. But once we get to the new stuff, the new material, it's hard because we're not going to be able to interact with you guys and get immediate feedback, immediate questions, immediate corrections, all that kind of thing. So it's kind of a learning process for all of us. I hope you guys can bear with us, but hopefully this stuff will prove to be useful and stuff like that. So on a complete side note, before I go, guys, I hope you guys are staying healthy. This is quite the odd situation for all of us. None of us have kind of been through anything like this, so stay healthy, stay positive, right? I know a lot of you probably haven't left your house in a while, but just keep your spirits up, keep your positivity going, and everything's going to be good, right? So have a good day, guys. Bye. Bye. Oh God. Oh, my thing turned off. That was embarrassing. Okay, now bye. Now bye.